This question is a mixed function. There's a cube and a reciprocal. It tells me x is not equal to 0, which that's a clue about there's an asymptote. But the first thing they want you to do is calculate the value of the function at 2. And when they use the word calculate, you do need to write down some work. So we just substitute 2 for x, and this we can actually kind of do by hand. 2 to the third power is 8, and 48 divided by 2 is 24. We get our answer 32. Of course, we can go to our calculator and just check that we've done that work correctly. I have the equation in my calculator, go to the table, and look up the value of 2, and it will confirm the fact that yes, I did the math right. It's 32. Part B, they want you to sketch the graph of the function, and again, making a sketch, you need to use the scale, or at least label the x's to what they've asked. So -5 to 5, -200, 200. That's the same window I'm going to use on my calculator to graph the function, so I get an idea of what it looks like. And there I can see, yes, there's an asymptote at x equals 0, or the y-axis, and that the function is a bit symmetric. So I can start to sketch the graph. And I'm much happier with the left side than the right side, so let me try that one more time. That looks a little bit smoother, not quite symmetric, but it gets pretty close, and that's the best we can do for our sketch. Next, in part C, they asked you to write down the coordinates of the local maximum point, and there's a reason why they're using this term local maximum. As you can see, the graph goes off to something above 200, but it's not really a maximum point. But over on the left side, that's typically what we think of as a maximum point, where the function has gone up and then started to come down. And so that's what we refer to as a local maximum. And from there, we just jump back to our calculator and calculate the maximum. And I'll show you a nice little shortcut, save yourself some time. When I choose the maximum, the calculator is going to ask me about left bound and right bound. Basically, I know that the maximum is somewhere in there, so choosing the left bound at 4, -4, would be a good choice, and I can just type that in. I don't need to use the arrow keys to sort of scroll back and forth, which sometimes can take some time. My right bound, -1, seems like a reasonable choice, and then my guess, somewhere between -1 and 4, I'll guess -3, and we find out the maximum is at -2 and -32. And again, calculator is giving me a few decimal places, but we can see that really it should be -2. So I just need to write down what the coordinates are of that local maximum point. And I'm also going to go back to my graph and just make a mark on the y-axis to indicate for myself more than anything that maximum point's at -32. And one thing to go back, thinking of the graph, it's symmetric, and so that tells me that even though my sketch isn't exact, I should know that that is going to be +32. And if my graph was more accurate, the x value should be right above 2, or the minimum there. And why am I interested in that, or thinking ahead? And that is when I look at part D. Part D wants me to find the range of f. And so the range of f is what y values does my function take. And so again, we know that on the left side at -32, my function goes down in the negative direction. And on the right side, my function starts at 32 and goes up positive. And there you can see we're using the fact that that's symmetric to know what that minimum value is without necessarily having to calculate it. So my range, y is going to be less than or equal to negative 32, or, and it's or as in the union, put the two together, y can be greater than or equal to 32, and that describes the range of the function. And again, there are two distinct sets of values, and we're connecting them with the word or because it could be one or the other.